Okay, we'll discuss on manual analysis and design of G+1 building. As many of you know how to design the buildings using softwares and many methods. Okay, I think some disturbance is there. Okay, 5 people have joined. Monish, fine. Okay, I am looking for the more strength. Okay, I'll wait for another. As I said, I'll be taking at 12:15. Okay, I'll wait until 12:15. Exactly at 12:15, I'll start the session. Six people have joined. Okay, ask your friends to join. Somebody, okay. I'll wait for another 5 minutes until 12:15. I think this will be quite a useful session, okay, among all previous sessions. Okay, many people in your academics also will not be able to learn the manual analysis of G+1 building. Okay, if the different structural element will design. Okay, design procedure is quite easy. Okay, we'll follow the same procedure as we do in the general analysis and design. But the thing is that how to distribute the load. Okay, we have discussed one session on distribution of load of one room. Okay, that is quite introduction session on introduction session. Okay, so we'll be dealing or discussing with a 3-room or generally what requirements will be there. Okay, one building, either 1 BHK or 2 BHK building, whether two with 2 floors, ground and first floor. Only 5 people are there. Okay, if I get around 20-25, then only I'll continue, or otherwise just I'll skip this one. Okay, here I am taking a simple building of size, okay, room size 4 meter by 4 meter, and it is 2 meter by 4 meter, and it is 3 meter by 3 meter. These are the dimensions, right? Okay, including wall thickness, the dimension of this building will be around. Okay, we'll consider a 9-inch or 230 mm wall on at all locations. Okay, either partition as well as the exterior walls are of same. Okay, here these are the beam locations as I. Okay, one column, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, this is all about your preliminary the column locations. Okay, in this way when you draw, okay, when you do a drawing, okay, there what I will do, okay, I'll go for this one, right? Okay, these are these are the whatever green lines are there, that is column locations, and gray lines are there, those are beam locations. Okay, so here I'll draw this beam. I'll draw this beam. Okay, these are the dimension 3 meter by 3 meter is there. Okay, so what I will do, obviously these are the two-way slabs. Okay, and it is 2 by 4. Okay, even you can check these room dimensions. Room first one, 1, 2, 3 and 4. There are 4 rooms. We need to distribute to the columns. First what I will do, I will notify the columns. Okay, where exactly I can fix the. Okay, this is column number 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, these are the column locations. Even you can write C1, C2, C3, C4, C5, and it is C6, C7, C8, C9. Okay, these are the column locations. Now I'll write the beam locations. Okay, it is B1, B2. First I'll notify, okay, the beams B4, B5. Okay, next 10. Okay, in this way we will not beam locations. Okay, there are is a two-way slab. It is also two-way, and it is 2 by 4. Okay, this one is 2 by 4. That means 4 by 2. Exactly, it will be 2. Though which one will take? Okay, you may go for even the span of this slab is only 2 meter, which is less than 3.5 meter. You can go for one-way slab. Okay, I'll go for one-way slab. Okay, so first what I will do, can I start the session or I need to wait? Please reply. Okay, only as 9 members are there online, as it is very less strength. Okay, if you want, I can wait for another 5 minutes. Okay, I'll wait for another 2-3 minutes so that I can call people. 12 members have joined. Fine. Okay, another 8 members. I'll wait for another 8 members. Just to call your friends. 8 known as came from 8 I think. Is it clear? Audio and video both are clear? Please let me know. Please message if it is clear. Okay, fine. I think it is clear now. Okay, just tap to retry. Okay, you'll be getting. No, I think it is clear now. Please check. Please check. I'm not getting any replies. Please let me know so that I can continue. Clear. Okay, Tanvir said clear. Any other 1 or 2 replies? Any 1 or 2 reply? Okay, fine. Now it's clear. Tanvir said continue, sir. Okay, Amaresh, fine. Okay, so I'll continue. Okay, here the load intensity need to be calculated here. Okay, load intensity is the combination of dead load, live load, floor and plaster finish. You know very well. Okay, dead load I'll be taking how much? If the slab thickness is 125 mm. Okay, so here I'll be taking 1 into 1 into 25 because that is density of this is the thickness volume into density of concrete, that is 25 kilonewton. Okay, generally the spans is around, the maximum span in this building is only 4 meter. Okay, so the slab thickness is around 125 mm is sufficient, I think. Okay, so what I will do, okay, so here intensity will be how much? 0.125 into, okay, I think it is something 3.25 or 3.5. okay, kilonewton per meter square, whatever it may be. Okay, and live load you take for residential live load, I will be taking how much? I will be taking 2 kilonewton per meter square. Okay, so floor and plaster finish I will be taking how much? 1 kilonewton per meter square. Okay, so the total load intensity, okay, the total load intensity among dead load, live load and floor finish will be equal to, okay, it will be equal to 6.5 kilonewton per meter square. Okay, so for residential buildings I'll be taking a total load intensity of 6.5 kilonewton per meter square. Okay, now first, before that, I need to find out how exactly the load is distributed from slab to beam to column and column to footing. Okay, we already have had one session on the load distribution, but when you take a full building, okay, the same concept will little bit change. Okay, so here what I will do, I'll redraw this figure once again. Okay, I'll redraw this one, that is okay, it is 3 by 3, 4 by 4, 2 by 4. Okay, these are the dimensions. Okay, 3 by 3 meter, and it is hall is 4 by 4 meter and 2 by 4 meter. Okay, these are the panel, slab panel dimensions. Okay, so here what I will do, okay, I'll distribute. Okay, I'll draw once again. I'll draw once again. Sorry. this is the actual shape of building, right? Okay, here we know, okay, it is a square slab. Okay, load is distributed exactly at an angle of 45 degree. Whereas it is one-way slab, we have considered one-way slab. Okay, so whatever the load is there, okay, so this load is distributed to, this is B1, this is okay, in this way the load is get distributed in one-way and two-way slabs. As it is panel is square, okay, so one way only one direction, whereas in two-way slabs, okay, exactly the load is distributed in two directions. Okay, here what happens, okay, so this is B2, okay, B3, like that we got different beams, right? Okay, we have given the notations, right? Okay, so here what happens, I need to find out area of this portion. Okay, area first, I need to find out first area of this triangle. Okay, how much it will be? How will find out area of this triangle? Simple thing is there. How many triangles are there? 4. Okay, this is 3 meter by 3 meter, right? Okay, the slab size is of 3 meter by 3 meter. Okay, so here what happens? If it is 3 meter by 3 meter, okay, the total area is 9 square meter, right? Is it clear? So there are 4 panels. Okay, if there are 4 panels, what is the area of one panel? 9 divided by 4. How much it will be? Please, anybody reply. How much it will be? Can anybody reply? I think, am I audible to you people? Oh, 2.25, fine. Okay, so area is 2.25 square meter. Okay, area of one panel is 2.25 square meter. Yes, fine. Okay, next. Okay, so all the areas I need to write. Okay, here what I will do, I'll write areas here. Just I'll remove the arrows and I'll write area. Okay, so here I'll write 2.25, 2.25, 2.25. Whereas this one is 4 meter by 4 meter. Whatever the whole portion is there, it is of 4 meter by 4 meter. So it is of 16 square meter. 16 by how many panels are there? Again it is 4 panels. So it will be 4 square meter, right? So area of this one triangle is 4 square meter. And this one is how much? 2 by 4. Okay, 8 square meter is there. There are only 2 panels. Okay, as it is one way slab. Okay, so it is 8 by 2. That is, again it is 4 square meter is the total area. Okay, so here also I will write 4 square meter. Is it clear how to just find out the area of these triangles? Later we will find out how exactly the distribution is going to happen. Okay, that we need to find out. Okay, I think 9 by 4 is 2.25. Okay, Akhilesh, it will be 2.25. Is it clear how exactly the distribution happens? And first we need to write the areas of these triangles. Is it clear? Please reply. Only 12 members are there. As I said, it is quite interesting session as compared to the previous sessions, and it will be, okay, whatever the session is there, it will be quite helpful for your future. Yes, fine. Okay, now I'll switch to the next part. Okay, so what is that? If this slab, for example, I need to find out the load on beam. Okay, I need to find out load on beam B1. Okay, now tell me from where you'll get the load on beam. From where you'll get the load on beam. Okay, either from the slab or from the wall. There are two possibilities, one from slab, first one from slab, second one from wall over that beam, right? Okay, there are two possibilities. Okay, first, as it is G+1 building, the, okay, this is footing, okay, and this is plinth beam, roof, okay, and next roof beam. Okay, there are 3 level beams you will get. Okay, one is plinth beam, beam at first slab, beam at second slab. Okay, so this is ground floor and first floor. Okay, this is the elevation of this building, right? Obviously, Sandeep, it is from slab as well as from wall. Okay, so here it is 8 by 2 is 4 square meter, right? Okay, so here what happens, okay, all these areas we have calculated. Now what I will do, I need to find out load on the beam. Here what I will do on to calculate load on the beam B1. Okay, intensity is how much? Beam length is length of B1 is length of B1 is equal to 3 meter, right? I need to find out the total load on the beam. Okay, so here length of B1 is 3 meter. So what is the total area and intensity? Area of that slab panel which is carried by the beam B1, right, Prashant, right? It is 3. Okay, so here the B1 is that. Okay, here in B1 carries a load of this one. B1 carries a load of this portion, right? This triangle. Okay, so area of this triangle is how much? It is equal to area, load on B1 is equal to area into intensity. Area into intensity on slab, including dead load. Okay, that means already we have taken. Okay, we can see. Okay, here we have taken intensity on the slab is equal to how much? 6.5 kilonewton per meter square we have taken, right? So area, you know, that is 2.25 into intensity is how much? 6.5. So what is the total load on this 3 meter beam? Just check it once. 2.25 into 6.25. This is 14.06 kilonewton is the load on the beam. Okay, so this is due to how much? One slab. This is due to one slab, right? There are 2 slabs are there, 1 and 2, right? Am I right? And now I need to find out, this is from the slab, load from the slab, and again I need to find out load from beam. I need to find out, right? Load from beam. Okay, here what happens? Generally this height is 3 meter. Okay, residential buildings have clear height of 3 meter. Is it clear? Clear height of 3 meter. Okay, Mega, you got 14.625, whatever, 14.625, whatever. Okay, so here I need to find out load on the beam. Okay, here what happens? This carries, as I said, okay, all the walls are of 9-inch thick, that is 230 mm, right? All the walls are of 9-inch or 230 mm. Okay, so width of the wall is 0.23 and the total length is 3 meter. The total length of this beam is obviously how much is the length of beam? That will be the length of wall. Okay, for one floor how much it will be? 0.23 into 3 into, okay, height is also 3 meter. 3 meter is the length and 3 meter is the height of that wall, into thickness, length into height. Okay, you'll get volume. The density of brick masonry is, this is gamma B, density of brick masonry. So that is 20 kilonewton per meter cube. Is it clear? 20 kilonewton per meter cube. So what will be the length or total load on beam in kilonewton? Obviously it is kilonewton per meter cube into meter cube. You will get the load in kilonewton. It is how much? 41.4 kilonewton. Okay, 41. Obviously, Tanvir, 41 or 41.4 kilonewton. Okay, now I'll switch to 41.4. Obviously, Shivkumar. Exactly. Okay, here what happens? The load due to slab is 14.6. Load due to slab is 14.06, and load due to beam or load due to load due to wall. Okay, wall is equal to how much? 41.4. Okay, together how much it will be? Okay, this is load on beam B1 is equal to how much it is? First one 14.06 plus 41.4. Is it right? 41.4. Okay, total how much you got? Total how much you got? It is around 55.46 kilonewton is the total load on beam B1. Is it clear? Total load on beam B1. Right? So here what I will do, load on beam B1 is 55.46. Now here there are 3 levels. Okay? There are 3 levels. Okay, I'll draw. 1 level, 2 level and 3 level. Right? Okay. Here what happens, suppose if this is G+1 building, okay, everywhere when you are going to construct 2 floors, you need to ask your client that how many floors you are going to construct in future. Okay, how many floors you are going to construct in future. Okay, generally the people will have a plan to construct another floor, right? So here what I will do, I don't know whether they will construct or not. Okay, but I'll consider either 1.5 meter wall over the slab, or you may have the 3 meter wall. Okay, so if you think that this is 3 meter wall over the last slab, means this is a G+1 building, means in G+1 building there are 2 slabs, right? One is a ground floor slab, another one is of first floor slab, right? So here what I will do, I will consider this is 55.46 load, 46 kilonewton on B1. This is B1. Okay, at every level, okay, it is named as B1 itself. Okay, so this carries 55.46. Also this carries 55.46 because these 2 slabs will carry, this is first slab and second slab. First slab and second slab will carry a load of 55.46 kilonewton. Okay, 55.46 kilonewton, first and second slab. But in plinth level, we don't have any load on the slab. Okay, we don't have any load from the slab. So, okay, so this is from the load from the slab, and this is from the wall. Okay, here the plinth beam only carries load of wall. So I will be writing 41.4. Okay, so these are the total load, 41.4 kilonewton. These are the loads carried by beam B1 at 3 different locations. Okay, at 3 different levels, right? Is it clear? Please let me know whether it is clear or not. Please let me know. Okay, here one thing, we will neglect the self weight of the beam. Okay, we will be neglecting the self weight of the beam as compared to the load acting. Already we have taken intensity on a higher side, 6.5, as well as we are considering a total of 3 meter wall. Actually what happens, if there is a clear distance of 3 meter, okay, there are only 150 mm will be the less, okay, because of beam the height of wall will be decreased by 150 mm because there is an interruption of beam. Okay, so total height of the building, if it is 3 meter, the height of wall will be around 2.85. Still we are taking 3 meter. Okay, so that because of that only I am neglecting the self weight of the beam. Is it clear, Shivkumar? Okay, so here what happens, Shivkumar, here I am going to construct another floor, right? You'll get another 3 meter wall, right? So here what I will do, okay, load intensity on this beam I am taking whatever the actual load intensity is there, 55.46. okay, and the first slab also carries load of wall as well as load of slab. Okay, so I'll be taking 55.46. whereas when it comes to plinth beam, plinth beam will not have any load from the slab, only it carries load of the wall. Okay, that's why I have neglected the 14.06 here. Okay, only I am writing 41.4, which came from the load came from the wall. Okay, only I am writing because the plinth beam carries only load of the wall. Okay, so now here in a similar way what I will do, I will be finding value of B2. Okay, B1 B2 will be same. Okay, I can write B1 and B2. Okay, B1 and B2 will be same. Next, when it comes to B3, B3 will be quite difficult because it carries a load of this slab as well as this beam. Okay, there are interruptions are there. Okay, one slab, two slab and a point load. Okay, before that I need to find out this one. Okay, load on this B1. Okay, how much it is? This is B1, B2. What is the B10? Okay, I need to find out load on B10, right? So here what I will do, I will be finding load on B10. Can you able to find out B10 load? Can you please work out and tell me the value? Okay, B10 carries, okay, I'll take this one. Sorry. This is B10. Okay, load on either side of B10 is 2.25, 2.25. Now tell me what is the load on B10? Total load on B10, how much it will be? There are two slabs and one beam is there, so obviously you'll have one wall, right? So load on B1 is, this is 2.25 loads. Okay, as I said 2.25. If it is 2.25, total load is okay, load on the slab is 14.06. So it will be around how much? Okay, obviously 5 square meter. 2.25, it is 4.5 square meter. Okay, so I'll be writing 4.5 square meter into intensity of 6.5. How much it is? It is 28.12 kilonewton. Please check it once. 28.12 kilonewton. Anybody? Okay, 2.25 into 6.5. Okay, Prashant, exactly. 2.25 into 6.5 into 2. Obviously, into 2 means it is around 28.12. Is it clear? 29.25. Please check it once. I don't know exactly. 4.5 into 6.5. How much it is? 29.25. Okay, fine. Okay, it is 29.25. Whatever loads will get. Okay, 29.25 kilonewton. Okay, which is on the beam B10. That is load on beam B10 is equal to how much? 29.25. Okay, this is 29.25 plus load from the wall. Okay, even it is of 3 meter. Load from the wall is equal to how much? 0.23 into 3 into 3 into 20. How much it will be? Total load much load you got total? 70.65 kilonewton. This is the load on B10. Is it clear? 70.65 exactly. Is it clear? Is it clear? Please reply. I'm not getting any replies from you people. Okay, 70.65 is the answer. Okay, it is correct. Okay, yes, fine. Shiv and Sagar. Okay, thank you. Okay, next I'll proceed. Here what happens? If it is 70.65, I'll again. Okay, now when it comes to this one, okay, I can easily write the load on the slabs. Okay, so here what I'll draw, I'll redraw this one. I'll redraw. Right, this is the location of beams, right? So this beam B1, okay, I'll write the notations also. B1, B2, B3, B4, B5, B6, B10. There are 12 beams, right? Is it clear? Okay, now here this beam carries a load of how much? B1 carries how much? B1 carries a total load of 55.46. Okay, B1 carries a load of 55.46. Okay. This is 55.46 and B2 also carries a load of 55. Obviously B8 is also quite similar. Okay, B8 will also carries a load of 55.46 and B12 is also same. It also carries a load of 55.46. Is it clear? Is it correct? Obviously same load is distributed, right? So same triangular load is distributed. So B1, B2, B8 and B12 is same. Now when it comes to B10 how much you got? 70.65. Here I am getting load of 70.65. Okay. Now I need to find out the total load. First I need to find out total load on B7, B9 and B5. Okay, before B3 and B4, I need to find out B7, B5, B9 and B11. Okay, so this is you know how to calculate. Okay, how exactly the triangle is taken into consideration. Now the load on B7. How will find out load on B7? Okay, the total area of the slab into intensity. Okay, load on B7 is equal to area into intensity. Okay, so here what happens? Area is equal to how much? Area of this triangle, you know, already people have calculated. Okay, area of this portion is how much? 4 square meter. Okay, is it clear? Okay, you know the intensity also already we have calculated 6.5. Okay, it will not change. Okay, so area is 4 square meter into intensity 6.5. So what is the total load from the slab to a beam B7? Can you able to calculate and tell me? 26. Obviously it is 26 kilonewton. Okay. Now load from wall is equal to how much? What is the length of wall? What is the thickness of wall? It is 0.23. Length of wall is 4 meter. Height is 3 meter. Intensity or the density of wall we are taking how much? This is gamma B. Okay, brick masonry. Okay, this is length, height, and this is thickness. Okay, so this one will be equal to how much? Only 9 members. I don't know why. I think whether it is interesting or not. Whether this session is interesting or not. Point 23 into 4. This is 4 into 240. 240 into 0.23 into 4 into 3 into 20. How much it will be? 55.2 exactly. Mega is correct. Okay, 55.2 kilonewton. So what is the total load on B7 is equal to how much? Total load on B7 is equal to 26 plus 55.2. How much it will be? 26 plus 0.23 into 4 into 3 into 20. Exactly, Prashant. Okay, it should be 0.23, not 23. Okay. So how much it will be? 81.2 kilonewton. So here I will be writing. Okay. Here I will be writing. Sorry. This B7, load on B7 is equal to how much? 81.2 kilonewton. Is it clear? Okay, now obviously B5 also I will be getting a same load on B5. Okay, it is also 81.2 because we have column locations. Okay, I'll show the column location also. Okay, this is 1, 2, 3, 4, 5, 6, 8 and 9 column. 9 column locations, right? So we should find out one column to another column. The span is treated as one column to another column. And B5 and B7 will be same, right? Is it right? Because of the same intensity distribution, right? Is it clear? Okay. Next, I need to find out load on B11. Okay. First, I'll find out the outer beams load on B11. Okay. So here I'll be taking. I think it is clear now. Load on B7 and B5. Okay. So now I'll switch to load on B9. Sorry, B11. Before B9, I'll be going to load on B11. Okay, how will calculate load on B11? One is, this is distributed, right? Area of this is 4 square meter, right? So area into intensity. The similar method I need to adopt. Okay, 4 into how much it is? 4 into intensity 6.5. How much it is? Already we have calculated 4 into 6.5. How much it is? 4 into 6.5? 26 kilonewton. And the span of beam is equal to how much? Span is equal to 4 meter. Now load due to wall. Load due to wall is equal to how much? Load due to wall is equal to thickness of wall 0.23, length is 4 meter, height is 3 meter, and density of brick masonry is equal to 20. What is the load here? What is the load here? Can anybody tell me what is the load? Obviously, Prashant, is the same procedure need to be adopted. Okay, 4 into 3 into 20. How much it will be? Can anybody tell me, please? 0.23 into 4 into 3 into 20. 55.2. 55.2. So the total load on B1. Total load on B11 is equal to how much? 26 plus 55.2. I think it is also 81.2 kilonewton. So now I'll write the load on B11 is equal to 81.2 kilonewton. Is it clear? Is it clear? Yes, fine. It's an offering. Okay. So next I need to find out. Okay, I'll wrap this one. Okay, I need to find out load on B6. Is there any load on B6? B6 is also remaining. Is there any load on B6? Yes. Okay, can you able to tell me which load is acting on B6? Can anybody tell me which load is acting on B6? Okay, I think network is clear now. Okay, wall load. Perfect. Okay, Ravi Kumar. N. Nandipati Ravi Kumar. Fine, Ravi Kumar. Okay, so here B6 carries B6 span of B6 is equal to how much? It is only 2 meter. Okay, and load on the B6 is we don't have any load from the slab, right? We don't have any load from the slab. That is how is equal to how much? Load on B6 is equal to only I'll be writing span of beam 2 meter, or before that I'll write the thickness of wall. Okay, load on B6 is from wall itself. Okay, so thickness of wall is 0.23, span of beam is 2 meter, and height is 3 meter, and the density of brick masonry, that is 20. So what is the total load on beam B6? What is the total load on beam B6? How much it is? 0.23 into 2 into 3 into 20. 2 into 3 into 20. 27.6 kilonewton. Is it clear? Okay, so I'll be writing a load 27.6 kilonewton on B6. Okay, fine. Megha and Shiv Kumar. Exactly. Monesh, yes, fine. Sana, exactly. Okay, here what I will do. Okay, so remaining beams are B3, B4 and B9, right? So first what I will do, I need to find out load on B4. It is quite difficult as compared to the previous one. Okay, load on B4. Okay, so here what happens, okay, if it is B4 is the span of beam, load on B4 is equal to what? First one is wall load, that is before that I'll take first this one itself. Okay, load from the slab itself. Okay, 27.6 will be there on B4. Apart from that, we are getting a load from this slab also. Okay, load from this slab also. Okay, so here what happens? Here what I will do? Okay, load on B4 is equal to, what is the total area? Total area is equal to how much? Area of this portion 2.25. Okay, so here what I will do, the span of this total beam is 3 meter, whereas before is only of 2 meter. So I'll write 2 by 3. Okay, 2 by 3 load on before is equal to 2 by 3. Okay, the total span of this before is 2 meter, right? Total length of this the beam which carries the load of this panel is 3 meter. So that's why I am writing 2 by 3. Is it clear? 2 by 3 is clear? Why I am taking 2 by 3? Because of only the span of beam is 2 meter, whereas this panel, okay, I can able to calculate area of this panel, right? So here what I will do while calculating load on before from slab is equal to 2 by 2/3 of 2.25 is the total area into the intensity 6.5. So now this one is here we are calculating this panel, load from this panel for a length of 3 meter, right? Okay, actually the before length is, the length of this beam before is only of how much? It is only of 2 meter. Okay, so I am writing the span of this beam and total load distributed. Okay, that is of 3 meter, right? Okay, here. Okay, here what happens? The total load distributed is, yes, calculate the area of triangle. Exactly, you are right. Okay, here what happens? Total load is distributed to 3 meter, but our beam span is only 2 meter. Okay, that's why I am taking this portion 2 by 3. Okay, 2 by 3 to 2.25 how much will be? 2 by 3 into 2.25 into 6.5. How much it is? 9.75 kilonewton. It is the load carried by the beam before. It is the load carried by the beam before. Here what I will do? Sorry, I'll wait for a minute. Okay, this is before. Okay, so this is of 2 meter, right? Okay, this is of 2 meter. These are the column location, right? So before load on the slab, that is before is 9.75 kilonewton, and load on load on beam before from wall is equal to how much? Already we have calculated. Load on beam B6 is 27.6. That is because of wall. And load on before is also same. The 2 meter is there. That is nothing but 0.3 into 2 meter into 3 meter height into 20 distance. We will be getting 27.66. 27.6 kilonewton. One is load from the slab is 9.75 kilonewton, and load from the why is not clear? Wait. It might be the network problem. Wait for a minute. Load from okay, I'll wait. I'll wait for 1 minute. Okay, because the network problem may be there. Okay, check now. Is it clear now? Can anybody check? Is it clear now? Kumar, okay, at least you wait for 2-3 minutes. No sir, not clear. Okay, wait. I'll wait for another 1 or 2 minutes. Okay. Please wait. Stay online. Is it clear now? Okay. You will do one thing. I'll end up this session and I'll rejoin within 2-3 minutes. Okay. You just stay online. I'll end up this session. Okay. I'll once again I'll log in with another page. Okay. Just stay online. Please, you stay online. I'll complete this one today.